Hi all. See this particular problem which appeared in JEE Advanced 2019. So first we understand that problem. It says that we are having a given function which is already given in our problem, right? You can see that it's a huge function, but the range and everything is defined. So different range, it's actually defined in the same way. But one thing we understand that from 0 to 3, right? It's actually a polynomial function, right? So every case is a polynomial kind of thing, right? Everywhere is polynomial. But in next case that it's a logarithmic function and all that stuff. Now we have to check that what's the option is given. It says that differentiable, increasing or decreasing onto and according to the maximum and minimum, right? So therefore we understand that we need to find out that f dash x, right, to interpret these options, right? So let's go ahead and find out the f dash x. Now how we go ahead and find the f dash x? Obviously step by step, right? So let's go ahead and write that f dash x. So here it's given that let us consider that in the interval x less than 0, okay? So if I consider the interval x less than 0, okay, it's given that the function fx, it's defined as x to the power 5 plus 5x to the power 4. Then we have 10x cubed, then 10x squared 3x1. So now if I trying to differentiate this, right, let's differentiate that f dash x gives me that 5x to the power 4 plus 20x cubed plus 30x squared plus 20x and plus 3. So that's the function of f dash x, okay? Now we have to check care of the next function. What's that? The limit, it's 0 to 1. So function again changes definition. So now we'll consider that 0 less than equal to x and less than 1. If we consider that, now function is redefined as fx, which is much easier, which gives x squared minus x minus 1. So x squared minus x minus 1. So therefore, plus 1. If I differentiate now, we'll get it as f dash x is actually equal to 2x minus 1. The last thing, that's again a polynomial function, so it's 1 to 3. So 1 less than equal to x less than 3. That's imply that my function fx is equal to 2 by 3x cubed minus 4x squared plus 7x minus 8 by 3. So if I differentiate now, f dash x will be gives that 2x squared minus 8x plus 7. So all the f dash x is calculated. Now only one part is left, that's x greater than equal to 3. So let's consider that as well, x greater than equal to 3. And then my function fx is defined as x minus 2 log of, so I write ln of x minus 2. Then we have minus x and some other constant 10 by 3. So therefore, if I differentiate now, we'll find f dash x is equal to x minus 2 will be as it is, log of that will come x minus 2. Plus we have that as log of x minus 2 because we are differentiating x minus 2 minus 1 and that's it. So therefore, it gives me that log of x minus 2. So all that options, right, we are able to evaluate the function of f dash x. So just rewrite that. So just recollecting all those information, right? So therefore, we can see that f dash x here, it's defined as in this form of 5x cube and all that stuff between that interval, okay? So let's write down in other way, in a proper way, okay? Let's go ahead. So therefore, you'll see that my f dash x will be equal to 5x to the power 4 plus 20x cubed, then 30x squared 20x plus 3. That's obviously defined as x less than 0. Next definition of f dash x is 2x minus 1. when our x is lies between 0 less than equal to x and less than 1. Next will be obviously that 1, 2, 3. That gives me that 2x square minus 8x plus 7x. That's obviously defined between 1 less than equal to x less than 3. And next one is obviously log of x minus 2. And that's defined x greater than equal to 3. So these are the definition of f dash x. So we are able to calculate f dash x. So through f dash x, we are able to calculate that f is increasing or not. Now see that it says f dash x, fs is increasing in minus infinity to 0, right? So let us check some arbitrary values, right? So here we consider that f dash of minus 1. So if I trying to calculate f dash of minus 1, so in this case, I'll substitute minus 1. So therefore, 5 into minus 1 whole to the power 4, that's 1, plus minus 20, plus 30, then minus 20, plus 3. So you can easily understand that it gives me that 38 minus 40, that's less than 0. So therefore, we'll say that f dash minus 1 is less than 0. So f dash if fx is not increasing, because we see that for the increasing function f dash x must be greater than 0. So here we find that it's not decreasing. So therefore option A is not the correct option. We only check that. Now also says that f dash is not differentiable at x equal to 1. That means we need to calculate the right derivative and left derivative, right? Let's calculate the right derivative and left derivative at x equal to 1. So let's go ahead and see that at x is equal to 1. If I want to calculate that left derivative, that is 1 minus h, okay, where h is tends to 0, okay, that's equal to, we can have to substitute 1 in this interval, right? So therefore we can see that it's 2, 1 minus 1, and that's equal to 1. So that's the left derivative. If I trying to calculate the right derivative, 1 plus h, right, we need to substitute 1 here. So therefore we'll get it as 2 minus 8 plus 7. So therefore, we can easily say at x equal to 1, right? If we calculate that the right derivative and left derivative on this case, right, we can see that's actually equal, right? That's it. So therefore, you can say it's 7 plus 8 and 9 minus 8. So that's equal to 1. So therefore, you can easily observe that the right derivative and left derivative are equal at that particular point. So therefore, we can say that obviously that function is differentiable at that point, right? So therefore, we say that f dash x is differentiable. Now, here we can see that here we prove with that fx and all that stuff, a minus h, a minus is that fx is differential, and that's obvious. But it says that f dash x is not differentiable. So that means we have to again find out that f double dash x. So let's calculate that f double dash x, okay? So if I calculate that, let's wait a second, I just calculate f double dash x. If I calculate that f double dash x again, we just differentiate it again. So therefore, we will see that it is 20 x cube plus 60x square plus 60x plus 20, and that's it. So this is the definition when x is less than 0. For the next case, it's obviously 2. And that's obviously 0 less than equal to x less than 1. Next case, it's obviously 4x minus 8x plus 7, okay? Yeah. So 4x minus 8 and plus 0. So that is 4x minus 8. Now see that here I just make a small mistake, okay? So see that here when I differentiate f dash x, right, it becomes 4x squared plus 7x, right? I just keep that 7x obviously. So that's a huge mistake, right? So that's x should not be there. So if I continue with that, then this way that 7x is missing, and that's why now it's correct, okay? So it's 4x minus 8, and that's it. Now we have to differentiate that log x minus 2. That's obviously 1 by x minus 2. So let's go ahead and put it as 1 by x minus 2. So all the differentiation is done. This is 1 less than equal to x less than 3 and x greater than equal to 3. Now see that here we need to find out that at x equal to 1, f double dashed 1 and f double dashed 1 at right derivative and left derivative, the same concept, right? So let's go ahead. So here we substitute that value and trying to calculate that f double dashed x, okay? Let's go ahead. So now, if we go ahead, we are able to find out that left and right derivative, if they are equal, so therefore that we can say that is differentiable or not differentiable. So therefore, we will calculate f double dashed 1 minus h, that is the left derivative. So that's obviously 2. And f double dashed of 1 plus h, that's obviously 4 minus 8, that's minus 4. As these two are not equal, so we'll say that as right and left derivative are not equal, so f dash x not differentiable. At x is equal to 1. So therefore, this option B is the correct option. Now see that what is the function of onto? Onto means that we have to see that range of fx is equal to all that codomain and all. Now here a function is given from R to R, and also see that most of the cases is as it is a polynomial function, right? So therefore the range will be definitely a polynomial function, right? So therefore we'll say that it from that case we can write it here as well, that range of fx is R. So the function f R to R is onto. Now see that here this R we don't write it because of that the function is defined from f R to R. No, it's not that. It's saying that as it's a polynomial function, that's why the range of the function is R, right? And that's why you can say it's onto. So therefore that's option C is also having a maximum, also having a onto function. Now see that for the last option is left. We have to check that. What it says that f dash x has a maximum value at x equal to 1, right? Now we already see that f dash x is not equal to f dash x doesn't exist, or f double dash x doesn't exist, okay? Because f dash x is not differentiable. So therefore we'll say that f dash x having critical point at x equal to 1. So we know that it's a critical point. Now when it's a critical point, so we can test that what will happen. Now see that if I substitute that f double dash 1, we do not find that it is greater than 0 or less than 0, right? So we can't say that directly, right? Now see that here, right? We can apply that value here, or we can go for the first derivative test, right? So always is better in this kind of problem when it's a critical point, it doesn't exist. It's always try to use that first derivative test. To go for the first derivative test as x equal to 1, I just consider two arbitrary points. So 1, this is I consider it as 0.5, and I consider another 0.2, okay? Let's calculate that value of f dash 0.5. Or maybe I just consider for calculation, let us consider that value as the 0.75. That will be easy for calculation, okay? Nothing else. So if I calculate that f dash at 0.75, what will happen? See that if I choose the 0.75, we have to choose this value, right? Because it's 0 to 1. So therefore, our function becomes 2 into 0.5 minus 1, that gives me that 1.5 minus 1, and that's greater than 0. So therefore, the function is having f dash x is greater than 0 at 0.5. If I trying to calculate the function value f dash 2, let's see what happened. F dash 2 means I have to substitute in this value, right? So therefore, f dash 2 it's equal to, let us substitute, 2 2s are 4, 4 2s are 8, minus 16 plus 7. So therefore, it is minus 1 and less than 0. So the function is less than 0 here. So that means that your function is increasing, right, from 0.75 to 1. So that's why it's an increasing function. And then from at 1, it starts decreasing because we have less than 0. So therefore, at this point, we will have the local maximum. So therefore, we'll say that as f dash x changes sign from positive to negative, so we'll say that x equal to 1 is local max. And that's it. So therefore, we will say that option D is the correct option. And that's it. It's a lengthy problem, but only the whatever the concept and everything we wrote, right? That's actually not required for a MCQ type problem, right? We have to understand that. So your job to understand that, finding f dash x and f double dash x. If I able to calculate that, the remaining all the self-explanatory, right? So that's it. Hope you understood it. Thank you.